let's see this theorems on derivative. Okay, what we have? Theorems on derivative. What is the meaning of theorem? Okay, theorem means the thing which we can apply to the problems. Normally formula is basically a thing or basically a numerical equation which will be helpful for solving the problem. Theorem means we can apply that concept to the problem. Okay, so here we have few theorems. So I just elaborated here. I have written these things here. So the first theorem is we have d by dx of f1 of x plus minus f2 of x is equal to d by dx of f1 of x plus minus d by dx of f2 of x. Okay, basically segregate. We have just segregated two functions. We have two functions combinedly, and then we have written those two function as in a different, basically segregated manner. Okay, similarly we have a next part here. As you can see that there is a k, one function which is given as k, and it is just a constant. It is multiplied with my function, and I can just remove it, or we can say that it is a coefficient of my function that can be written out of the derivative because it will not affect my derivative. The next part is that product of two functions. If I'm differentiating the product of two functions, what will happen? Okay, I'm gonna explain these things in a separate slide. So the first one, let's talk about the first one. Okay, the first one is combination of two functions, either addition or subtraction, doesn't matter. So what will happen here is, see, so if we have one function f1 of x and f2 of x, let us suppose I'm taking two functions here as I'm taking x square plus sine x. So this is my function which have x and y both. Okay, or else we can say that this is my nothing but f1 of x and this is my nothing but f2 of x. Okay, I'm writing f of xy here because it is just to represent two different functions, or else you can write in a different manner that f of 1 f x or f of 1 of 2, or here also you can write as f of 1 instead of writing xy because you will be confused with y. What is y here? We don't have anything y. So instead of that you can write here as this function is equal to f of x1 and x2. Okay, so basically this combinedly function. So we have two function f of x1. So if I have to differentiate, okay, if I have to differentiate these two functions, so I'll say that d by dx of x square plus sine x. I have to differentiate this. What I can do is I can do this separately. I can segregate them. So for same function itself, I'll take plus and minus because I'm explaining both the theorems in the same way. So I am taking plus minus. It can be plus minus, doesn't matter. Okay. Now d by dx, how to segregate is d by dx of x square and plus minus d by dx of sine x. Okay. See, you are doing separate differentiation of that separate function. Okay. So d by dx of x square is nothing but 2x. Okay. Plus minus whatever the sign is there given in the problem, you will use that one, and d by dx of sine x is nothing but cos x. Okay, so you have differentiated a combined function by taking two different functions and segregate them and get the answer. Okay, let's see the second theorem on these derivatives. What this theorem says is a very simple theorem. Okay, normally the differentiation of a constant quantity is 0. Okay, mostly student I have seen they are doing the mistake in this constant part only. See, if I'll say differentiation of any constant quantity, like any constant like k or 2, 3, 4, 5, anything, it will be 0 only. Sure, but we cannot call a quantity as constant when it is with the function. That is the very important point here. This is always, we can say this is a scalar quantity or constant quantity. It is basically a k is a scalar quantity, but since it is with the function, it is also known as coefficient of the function. Okay, So the point here is, when a constant quantity is with any variable, then it will not be, we cannot differentiate it as it as separately. It will be with the function, so it will not affect the differentiation. It will be written as it is. So you can see here as, so d by dx of k f of x, I'm just keeping k out and differentiating f of x. Okay, if you want to see the example, let's see, I have a function f of x, okay, which is given as sin x. Okay, sin x differentiation we know, which is nothing but cos x. If I'll write any number with this sin x, it doesn't matter, it will not affect my differentiation. So it will just say that f dash of x will be nothing but 5 cos x. Okay, it is not affecting my differentiation. There will not be a change in my differentiation. We can differentiate this sine function separately. Cos, this 5 will be with the sine, and same as 5 is coming with the cos. Okay, so this is my answer. Clear? Okay, let's see this theorem, guys. This is very important theorem. Okay, because this theorem is also known as a product rule. Whenever two functions are given in multiplication, whenever you will get any, not just two functions, 3, 4, 5, any function, but here, since this theorem says for two functions, I have two function, f of 1 and f of 2 of x. So what will happen in that? Okay, some of the probably you have heard about this by UV rule. Okay, u and v. Okay, u and v are two functions, two variables, we can say that, or two functions. So whenever the product is there for two functions, then how to differentiate in that? So first I will explain this part. So whenever we have a product of these two functions, so basically how to differentiate it, we'll keep one function as it is and we'll differentiate other one in the first time, and the second time we'll keep the first function as it is, second function derivative, and then second function as it is derivative, first function as a, okay, see, I will explain this part. First function as it is, derivative of second function, and second function as it is, derivative of first function. That's very important. You can, if you're getting confused with f of 1, f of 2, you can write this as d by dx of u into v, two functions. So u as it is, it will be easy for remember, u as it is, differentiation of v plus v as it is in the second time, differentiation of u. Very easy. I'll just give you an example on that. Let us suppose I have one function f of x, which is nothing but, okay, or we can say my differentiation I have to do for the two function, which is nothing but sin x and cos x. So here u, anyone you can assume u, anyone you can assume v, or anyone you can assume a first function and the second function. It is up to you. Okay, so it means if I'm taking this as a u and this as a v, okay, so what will happen in this case? So if I'll differentiate u as it is, so sin x as it is, differentiation of cos x. So first I'll write in terms of the formula. So it will be d by dx of cos x plus cos of x as it is, d by dx of sin x. Okay, so sin of x into differentiation of cos x is nothing but minus sin x. Okay, plus cos x as it is, differentiation of sin x is nothing but cos x. So what we got? Sin x into sin x minus, we have already sin square x, and here we have cos square x, and if I'll solve this, cos square x minus sin square x is my final answer. Okay, probably you would have learned about the trigonometric functions. So this is nothing but a trigonometric formula. So if you remember that formula, you can just simplify in one more step. This is as cos of 2x, like that. Okay, if you remember that formula, but I will not say that you simplify till this cos of 2x. I will say that keep it till cos square x minus sin square x. That is the only thing. Why we should go further? Because if you are not aware, you will get confused with that. So you will leave it as it is. This is the answer. Okay, once you learn the trigonometric formulation, you will be able to understand this is my result, and we can just go one more step. Okay, so this is what I got my differentiation of my function. So the function which I have taken as sin x and cos x. Again I'm repeating one time, first function as it is, differentiation of second, second as it is, differentiation of first. Okay, so you'll get the result. So this theorem is very useful, because many times you'll get the product of your different function, and it is not like that only for trigonometric functions. You can have a product of algebraic functions, exponent functions, logarithmic functions, so mod functions. So you will get, and you have to use always this rule. Okay.